Hello, Wharton students. Today, we're going to solve 2014 AP Calculus BC question 4. This question is about trains velocity. So there are a couple applications of calculus, and one of the popular application is applying and calculating the velocity and acceleration of a moving object. So first question asks us to calculate the average acceleration train A over the interval from T2, 2 minutes to T8, 8 minutes. We know how to calculate the average acceleration. So this is just the end of the acceleration time 8 minus the beginning of the acceleration. And then over 8 minus 2. So this would be the question for question A. So this is how we calculate the average acceleration. So we actually calculate this. We can see the chart here. So average velocity, average acceleration, the velocity acceleration at time 8 was negative 120. And at time 2, it was 100. But it is minus. So it's going to be 100 over 6, which is 111, which is negative 110 over 3. It's going to be meters per minute second. Okay. All right. I'm just going to put MIN to be sure. Okay. The next question asks, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t? Okay. So here we're going to use a critical concept from calculus called IVT, intermediate value theorem, for short, because we want to see if a particular value exists within the given interval. So we use, in that case, we're going to use IVT. So we're going to use IVT functions to show that they are continuous. We know that since velocity is continuous and also differentiable. So given as differentiable, and we also conclude that it is continuous. So I'm going to rewrite here. So given that it's differentiable, we know that it is continuous. So, okay, so from the table, we see that average velocity, acceleration velocity at time 5 was about 40 meters per minute. And it was negative 120 at time 8. So a continuous function must pass through every value between 40 and negative 120 as t moves from 5 to 8 continuously, right? So in particular, it must pass through one negative 100. So we conclude that negative 100 exists in between these values. So by intermediate value theorem, we are concluding, we're guaranteed that we're going to have negative 10 somewhere in between 5 and 8. All right. The next question, C. We need to find the position train A at time t equals 12. And at t equals 2, we know that train A is 300 meters east from the origin. So to find this position at t equals 12, we need to add the displacement between t equals 2 and t equals 12. So the speed of train A at t equals 12 is equal to the speed of train A at time equals 2 plus the velocity of A, t dt. So this is the instantaneous movement of the train A. This is instantaneous, and we're going to accumulate that from 2 to 12, right? So from the table, even though we don't know the exact VA dt dt, we approximate the integral using the trapezoid rule. So we can split the interval from 2 to 12 into 3 subintervals. So necessarily 2 to 5, 5 to 8, and 8 to 12. So for each subinterval, the displacement is approximated as the area of the trapezoid. So we're going to use the area of trapezoid here. So what is this? So the definite interval from 2 to 12, VA dt, VAT dt is approximately 3 over 2 times 10, 100 plus 40 plus 3 over 2, 40 minus 120. So these are the values of A at 12, 2, A at 5, A at 5, train A at 8, so on, right? Plus 3/2 times negative 120 minus negative 150, right? So after calculating each term, you can use calculator here. So this is going to be 210. This is going to be negative 120. And this is going to be negative 540. So adding these together, we find this is approximately equal to negative 450, right? We just calculated from the definite interval from 2 to 12. So we need to add the original value. Since we're starting from here at t equals 2. So the speed of train A at time t equals 2 was 300. So the final answer is going to be 300 minus 450, which is equal to 150. Right? So this is the answer to the question C. All right, so this is the last part of this question, part D. The final question D asks us to find the rate at which the distance between train A and B is changing at t equals 2. So let X represent train A's position. So let X represent train A's position. I'll say position of A, and Y be position of B. Okay, so distance Z from between the two trains. So let's say there is this and this, like a train A and B. How do we find this placement? Sort of like a distance. We can use Pythagorean theorem. So let's denote Z, all right here, Z, the distance between A and B, right? So if we use Pythagorean theorem, we can represent this as z squared is equal to x squared plus y squared, right? Because this makes the triangle. So this is z. Differentiating, let's first differentiate both sides with respect to t. That's what we were curious about. So 2z dz dt, we're using implicit differentiation. So 2x dz dx dt plus 2y dy dt. Let's divide just everything by 2 for simplicity. So what do we know? Z dz dt is equal to x dx dt plus y dy dt, right? Okay, so we substitute the values at t equals 2. We're given that x is equal to 300 meters. We're given in question C. And now the train B is 400 meters north of the station. So we know both x and y, right? So x is going to be 300 meters and y is going to be 400 meters. Okay. And how we calculate z, we use Pythagorean theorem again. So square root of this squared plus this squared, which is 500 meters, right? So now we need to calculate dx dt, dy dt, dz dt, right? So all we have to do is take a derivative and plug in the value of UA, the velocity of A at 2, right? It's already given. So this is the instantaneous change at t equals 2 right here, right? Okay, we know that this is 100 meters per minute, which is given. And this is going to be 225 meters per minute. This is the instantaneous change that we're given. So this is the velocity of train B at t equals 2, right? So let's substitute everything. So if we substitute everything, this one we still don't know. So we need to substitute 500 dz over dt is equal to 300 multiplied 100 plus 400 multiplied by 125. So if we calculate everything, this is going to be dz dt. This will give us dz dt about 160 meters per minute. So what does this value tell us? So we know that at t equals 2, the distance between train A and train B is increasing at a rate of 160 meters per minute. So this is the instantaneous rate, and we already decided that z denoting as the distance between A and B. So we finding dz dt, that would give us 160. That would be the rate of 160 meters per minute. I hope this explanation was helpful, and I'll see you next time. Thank you.